Okay, so this question, when you kind of scroll through and read to the end, it's asking for what's the molar mass of this compound. It's asking for that. And so there are two equations that kind of get us most of the way to getting to molar mass. So this is our molar mass equation first. That's not the compound that gets us on the way. This is the one we're going to ultimately use. And typically, somewhere in the problem, the gram amount is stated. So like right here, this is stated as a gram amount. It's talking about the non-electrolyte. So that implies it's talking about the solute. And then the idea is that you're going to end up being able to get the N from solving this one or this one for those circled terms. So the problem gives you KF information or KB information. So we would be using the lower one because that's the one that gives us the problem information. And the way we get from the little m, which is molality, is by knowing that that's moles of that non-electrolyte. Like when it's solved for m, over 1 kilogram of solvent. We still have to get it to just moles to be able to stick it in. It has to be, and when we get done with this equation, it'll be tied to kilograms of solvent. You don't want that. So somewhere else in the problem, it'll give you some information that will let you get to getting rid of solvent. So ultimately, we'll end up multiplying this, and I'm going to convert it in my head by moving the decimal 3 places to 220 kilograms of solvent. And then you can see how that will get those units to cancel. And then that's how we end up with a value that we can put in that top term. So that's the plan. We're going to go ahead and plug the information in. I have got delta T equals I times M times KB. Now notice it says non-electrolyte. So I'm going ahead and just take the I out because I is 1. 1 times anything is itself. So it just makes the problem easier. The next thing is that I've got to solve it for this pink term, the circle term. So I want to divide both sides by KB, and that will help me get the molality to itself. Oops, did not mean to erase the molality there. And then now I just need to fill in. So this is my change in my boiling point. So it went up to 64.5. minus 61.2. And when you're doing these, essentially you can think of this as just like absolute value. You can put, technically you should do final minus initial, but you can put either one of those in and you should be getting the correct value. Even in the freezing point ones, if you do final minus initial, you'll end up with a negative, but we've kind of talked about this where there's technically a negative in the equation to get rid of that negative, or you can just know that that delta T term is considered an absolute value term in this setting. So anyways, there's our temperature change. And then our KB is 4.68 degrees Celsius per molality. And notice that that is my degrees Celsius. So again, when you're dividing by a divided by unit, that is going to put our molality on top. That's going to give me my molality. So if I bring in my calculator, I'm going to have that my molality is 64.25. Bring that down so you can see it. So 64.5 minus 61.2 divided by 4.68. There we go. Now, the way I put that in my calculator was not the right way to put it in. And so that's a really easy error for someone to make. You have to get this top section in a parentheses. So I'm trying to get it over there. Parentheses, and then over here, one more parentheses. See the difference? So be careful. That's going to give me 0.70. I'm going to put some extra numbers in here. 1, 3. And that's my molality. And again, remember that I can always rewrite that as moles over an assumed 1 kilogram of solvent. Now, I just need to take that term and I need to multiply it times my 0.2200 kilograms of solvent. And that is going to just give me my moles. So I'm just taking that number times 0.2200, and that's going to give me 0.15, and I'm putting some extra sig figs in here, 155,128 moles. And then that is my pink term that I'm going to put in the equation. And then if I go up, I've got my green term up at the top. So the molar mass is going to be 35.7 grams divided by 0.155128 moles. It's in my calculator, so I'm going to say 35.7 divided by, and I'm just going to use my second answer key to put that 0.155 in it. And so it's telling me that my molar mass is 230.1 grams per mole. And again, these are probably going to tell you how far. Maybe you should take it out an extra decimal, but if you go way over here to the top and you're looking at this change right here, this was, when you do the math on that, you're going to have 3 sig figs. And then that had 4, but this one should have had 3. So as we go all the way through, we really should have technically rounded it to 230. Sometimes there are limitations in our system, and sometimes we might be like, hey, go ahead and, just round it to the ones place. So just, again, in Gen Chem 2, pay more attention to the question and how everything's phrased with that.